Good afternoon, everybody. Thanks for making it today for a presentation on streamlining threat hunting in cloud environments with Jupyter. Let's get started here. So the agenda for today, maybe starting with a quick introduction about ourselves and a quick introduction about threat hunting. What are the limitations of traditional threat hunting and why there is a need to adapt to a modern traditional threat hunting with automated tools in machine learning. We'll also deep dive into Azure logs, some fundamentals about Azure logs, O365 logs. Then we'll also look into some fundamentals about AWS CloudTrail logs in specific. Then we'll go into some Jupyter notebooks where Phong is going to talk about the Azure part of threat hunting with Jupyter on Azure environment. And I'll be talking about threat hunting in the AWS environment. Then we'll look at some takeaways and references. So I work as a senior security engineer at UI Canada. I do a lot of technical blogs, open source contributions on GitHub. I write a lot of code, and I'm also a data privacy advocate. In my free time, I actually read a lot of manga and watch a lot of anime. That's a quick introduction about me. Phong.
So me, same thing, MD and engineering in Azure or at the most in AWS sometime. You can find me on LinkedIn, usually for biking, hiking.
Yeah, if you scan this QR code, you should be able to find Phong. It's not a phishing scam. It's actually a legitimate LinkedIn URL there. Yeah, pretty question about hunting. So just going to read out this terminology here. Threat hunting is an umbrella term for techniques and tools organizations use to identify cyber threats. So threat hunting is basically a process where you look into a chunk of logs and you try to identify some threats which are hidden in there. And then you classify those threats as relevant threats or non-relevant threats to your organization. So some organizations, the threat might be, so the threats which are relevant to industry A might not be relevant to industry B. So it's very important that you understand what is a relevant threat to your own industries. And traditional threat hunting heavily relies on the expertise of an analyst who's actually doing the threat hunting. The modern day threat hunting heavily doesn't rely upon the analyst's ability to do the threat hunting, but more focuses on automated tools, machine learning, and chunking through a lot of data. If I have to classify threat hunting into types, then I'm going to classify them into three types: structured, unstructured, and ad hoc. Structured is all about looking for specific TTPs. When I say TTPs, that means techniques, tactics, and procedures. I'm going to look for specific things that are out there in the environment. I'm going to look for specific threats. I know what I'm looking for and I'm hunting for those threats. Unstructured is when I'm looking for IOCs. Suppose there was an exploit out there, there was a vulnerability out there, and I have got some IOCs from some open source intelligence platform, VirusTotal or FBI FlashBrief, and I want to hunt for those IOCs across my environment. I'm just going to do an unstructured threat hunt. And ad hoc is whenever you need it. Suppose there is a new vulnerability out there, Log4Shell or any other vulnerability, and you want to search if any of those IOCs are available in your environment, or you just want to do a quick sweep. So ad hoc is just whenever your clients require for it or when the time calls for it. Structured and unstructured are basically scheduled every day or every week, regardless of how your MDR provider or the SOC provider wants to perform those. So those are timely mannered, and ad hoc are whenever it needs. Limitations of the traditional threat hunting. We have too much of data these days for even an analyst to sit down and chunk through terabytes of data. Every company is currently moving into cloud environment, and then when every application is going into cloud environment, you're logging a lot of different types of log sets. It's too much of data to even hunt for threats. And that's why the first limitation, too much data, and the scalability part. When I have got like 10 terabytes of data, I run a query with some wildcards in a SIM solution like Splunk or Sentinel or QRadar, Logarithm. The scalability part becomes a question because I'm not able to perform a large scale threat hunting, and that needs to give me a near real-time threat detection. So that's a scalability problem. Static nature of hunt is basically when I know what is the threat I'm looking for, I write a detection query or a detection logic and I'm just going to hunt for that. But what if I don't know how it looks like? And also the evolution of malware and threat actors, the code just keeps on changing, the malware keeps on changing. So there is no way we can stick with the current detection rules and hunt for the upcoming threats. That's why we need something to identify unknown threats. If we don't know what it looks like, if there is a 0 day out there or a vulnerability out there which we don't know, then how are we going to hunt for those? That's what the presentations focus on currently. How are we detecting threats which we know, and how are we going to detect threats which we don't know?
So as I say, traditionally we have like log source, database, and since we create a database from the scene, and I was just create something for C like Splunk, Sentinel, But using Sentinel AWS query, sometimes we don't have like as much capacity to modify the data. For example, we have a bunch of phishing email. If many even subject, how you can do that to serve or custom queries. You can't do that. You have to export the data to Jupyter using High-Fidelity Detection to compare the schema streams and then you unfollow phishing email. And then we started this with Jupyter, like machine learning, we started for Jupyter for the we cannot do that team Sentinel also. Or if you use data explorer, this you have to hide our data to particle and then I impact to data explorer in order to use those things. And next, for Azure, we can talk about sign up, which we already have inside Infra use Azure. And then as Oliver, which is user activity. Next, graph data activity, which is new thing from Microsoft, which for every graph activity, such as when you open Teams. So in the background, you can search for user group, whatever. And then you can go to Azure portal when you search something in the search bar. You can look for user groups, also do for graph API and RPA. But these it's going to be lots of loss, going to cost you lots of money when you ingest some data into cloud service or on-prem. So you have to filter or summarize it all before you ingest. And then the last thing is Azure activity. All the other activity logs only by creating, modifying all of these Azure resources. Anything happen inside the resource, Azure activity is not going to log in. You have to log in yourself from Azure Diagnostic Log, like reading, hovering your off storage from what IP, who came listing the secret from the keyboard, who modify something. You have to go to the diagnostic log yourself. You have to ingest it also. So now Kai's going to talk about AWS.
I know it's a bit of juggling between Azure and AWS, but be with us, guys. Let me know if you have any questions regarding AWS Cloud Trail as I'm going through here. So AWS Cloud Trail is a specific type of log source which I'm going to talk about. There are different types of log sources on AWS. There is Guard Duty and there is several other, but then we only focus on Cloud Trail here. So Cloud Trail is going to record any activity that happens in an AWS account, regardless of that account is capable of doing an API call or a non-API call. So we have all those recorded inside AWS Cloud Trail. And I'm going to classify AWS Cloud Trail logs into 3 different event categories. The first one is management, second one is data, and third one is insight. So if I talk about management events is all about all those management kind of activities that you perform on your AWS account, like configuration of policies, registering your devices, configuring rules, routing data, setting up logging. Like all of these specific policies that you see or the specific event sources that you see, attach role policy, create default VPC, create subnet, create save. These are examples of the event sources which is available under management events. The next one we'll talk about is data events. Data events is all about any operations which is performed on or in a resource. Here we'll be looking at API activity on S3 object, Lambda functions executions, EBS or the elastic blocks, blob storage, direct API calls and snapshot. So all of these actions like get object, put object, delete object, snapshots, all of these actions are very important because that's what we are going to be using for our threat hunts. And the next one.
Inside event, yeah.
Oh, inside, sorry. Yeah. Inside events. Inside event is actually going to tell you about any unusual activity or an abnormal activity. So suppose, let's take a classic example here saying that an account that logs no more than 20 Amazon S3 delete bucket API calls per minute starts to log an average of 100 calls. So that's an unusual spike. Whenever there is an unusual activity of this type happens, what AWS does is it's going to create one log at the start of the activity and one log at the end of the activity. So 2 logs, which is going to tell the start of the activity and the end of the activity. And then we are going to take a look at the activity to see what that activity was all about.
So get on the ship, guys. We send you to Jupyter. Okay, this one. So first thing first, we go with page not. Go on this one. Is that yeah. Now no strips. Yep. Too big or too small for you guys? So first thing first, we use network X and then some simple property in Python. So I got my silent logs from Azure and AT&CK from a CSV. We can get it from blob storage or S3 or somewhere on-prem, depending on where you guys extract the log to. So as we can see, after grafting, we have user usually log in from this 104 IP, which is Cloudflare, like 46 event, 1 event, from all of them from Cloudflare. But when we investigating a log, we see this standout IP from Europe, which is 1217. Then now we type this inside of IP address. We can see that MFA pass, and then all of them seems no risk, right? Because MFA pass, usually we configure a policy. When MFA pass, let it go in and then dispute the risk. But in this case, when you in the man in the middle phishing, that is different story. Attacker already got the token for sign. So if we go after that one, we graph the unique token identifier, which is unique for every section, every user. So we graph that unique token. We go to the graph API log. So as we can see here, there's one spike during this time, like 4 billion bytes, which is 4 gigabytes of the graph API log within 30 minutes of being time frame. And then we go on. This is a log scale of that. We can see usually they just go like 5 megabytes, even 1 megabyte, couple bytes. And then, so let's see what happened with that IP address. So 4 gigabytes here from this IP address. We see the graph API, the user calling is 1 megabyte for listing row in entry. Like basically 1 megabyte, we can list most of the row inside the entry. And then the listing the group, like how many users in the group, who belong to which group, subgroup, or whatever group inside that one. And the notable thing, I only list like 1,000 users as already 4 gigabytes. So if your organization have 10,000 users, it's going to take like really quick 10-15 minutes to drag out all the user. And then depending on attacker, you can use like phishing email for those user or impersonate. Usually in the intra log, you have the on-premise ID also, as well as the user ID when you call for help desk for reset password, it verify with your employee ID, right? And then to pretend the persistent, we have to register MFA. Here is the Python log. Python code, you can see like get operation name from audit log, which is register security info or updating it. Is the event basically from the audit log. But this event doesn't tell you what device got registered or something changed. You have to look at the you update user operation before that, just before that's security info update. It's gonna show you here an iPhone. Here's my case. My phone is my phone. Sometimes say user phone or iPhone 13 something. But update user doesn't give you the IP address of the actor. And this thing is have different correlation ID inside the audit log. So correlation ID in Azure, which is same action, like in the same section. So when they log in, if they have enough permission or they activate their PIM access, you can disable diagnostic log, which like logging you read the block storage or read the key. In my case, I disable my block storage log for sending log to Sentinel. And also we have to disable the policy, in this case, the block storage policy, delete retention policy. So if I exfiltrate a lot and then I delete the whole blob storage, no one can recover in this time. As well as the defender for storage. Defender storage, for example, when I upload the malware to the storage or I try to exfiltrate blob data, they're going to alert and stop my connection to the blob storage and also disable my account. We can see here, when we disable the defender for blob storage, they also remove the role assignment, like so the defender scanner cannot access the blob storage. And then in order to exfiltrate, we have to modify the network security, which is NSG. Here, in my case, is allow any IP or outbound, inbound to that VNet, so I can exfiltrate those things easily using easy copy or honor technique. So after that stage, we can just easily delete all the data if we are attacker. So we can encrypt or ransom, delete snapshot, computing snapshot, delete the keyboard. But there's one thing, immutable policy here. So if you have an immutable policy set up for your blob storage, when you delete your container, it's going to be a failure. So as an attacker, you have to escalate your privilege to remove that policy in order to delete it. So after I remove that policy, down here, I'm able to delete that blob container. As we can see here, the storage account backup prod 1 is protected by the immutable policy. And last thing, when we operate the MSSP, we have lighthouse access to customer resource group or subscription. So as the attacker, I can set up, after compromise the whole tenant, I can grant my user from my tenant some lighthouse access to your subscription to prevent, to get this persistent in the future. So here we can say, usually when we deploy lighthouse, we need the ARM template. So we can say all these event is within same correlation ID. So within same action, we deploy the template, grant access. Also, this is also important thing, which is tenant register action. So in that action, we can see MSSP tenant ID, which is the attacker ID, tenant ID, sorry. And the other case is if the victim is the MSSP service, the attacker can move laterally to other client that MSSP has. So after compromising the whole tenant, if we have multiple cloud setup with SSO to AWS, the attacker also can use those accounts to single sign-on to AWS. So now I'm going to tell you guys how we can exploit AWS.
I know that was a lot of Jupyter code, but then we have a lot more coming up as well. So can I just ask you guys to take a deep breath because we have a lot of Jupyter coming up. Yeah. So what we do here in AWS is basically the exact same thing. We import some libraries that we need to run our Python code. The first one that we are going to be talking about is AWS Defense Evasion using impaired security services. What we actually look for is specific event names. So if you look at event names here, you can see like delete alarms, delete tags, delete policy, delete log group, delete something. So we can clearly see that the attacker is trying to delete some policies, delete some logs, delete some user groups. So some deletion kind of activity is going on, which is basically a part of defense evasion. So when we actually look for all of these event names inside our logs, so what I basically did was took all those logs into AWS API call x.csv, loaded that into a data frame and searching for these things against it. So in a production environment, instead of loading that into a data set, you can directly query your S3 bucket or you can directly query your AWS resource. For the sake of presentation, it's all in a CSV file and we are going to query that CSV file. So when we query that CSV file for all these different types of event names, we see some events here. And these events are basically the alerts which are going to be generated by this in action and going to be forwarded to your tier 1 for investigation or tier 2 for investigation. Moving on, we'll be looking at exfiltration via data sync task. So that's basically creation of a scheduled task which can perform various different activities. In this case, what we'll do is basically create a scheduled task that's gonna exfiltrate data from your given source called datasync.amazonaws.com. So we are looking for an event name called create task, and create task is basically any scheduled task creation, and that scheduled task creation is performed on an event source data sync, and then we are exfiltrating data using that. The exact same thing on Azure AD would be DC sync, where you sync those two DCs and take those data, and then you can exfiltrate data and do anything with that data. Moving ahead, we'll be talking about guard-duty detector recon. So, concepts or discovery, once you have got a foothold of an AWS account, you want to see what kind of resources exist there, what kind of list detectors, what kind of detectors are there in the given name. And here, what we see is a lot of false positive, because a lot of genuine activities or an admin privileged users perform the similar discovery activities. So what we do is exclude AWS service role for config, CloudGuard Connect, or any other user accounts which are like having the privilege to perform this activity on a business use case or on a regular use case. That's why we use these two as a filter, and then we only take for any other activity with any other user to performing list detectors activity. Moving ahead, we'll be looking for publicly exposed database instance. Again, here we are going to be looking at only for modified DB instance, and then anything which is publicly accessible already, and we know about that, we just exclude about that. So that's the filter of the suppression, and we only focus on modified DB instance. Moving ahead, we have changes to identity access management policies. So we'll be looking at create policy, update policy, delete policy. Anything which has been performed on these policies, which is not aligning with the business use case, you're going to investigate further on that. The next one is non-MFA console login. So the event name is console login, and then you're going to filter out anything which has got a successful MFA or a failed MFA, because if it's a failed MFA, we don't really want to look into those ones. So successful MFA login into console. Successful login into console without an MFA is what we are going to be focusing here. Next is AWS CloudTrail manipulation. Again, what we are going to look into is delete flow, delete event burst, delete activities, update activities, stop logging activities, which is implementing defenses or modifying or disabling defense tools. Now, let's go into some machine learning part. Not too much of machine learning, but starting part of machine learning. What we do is take the data, load it into a data frame. And what I did was basically extract two different things, account ID and who was it invoked by. Account ID invoked by our inside user identity. Just going to extract those two. And then if I just take a look at the error messages which I have, so only going to print a couple of 5 unique error messages in my data set. I can see user is not authorized to perform an activity, specific bucket does not exist, public access is not found, incorrect username and password, different type of error activities that we can find in our AWS account. So the purpose of this machine learning thing on the detection that we are trying to do, the use case is if I see a majority of a spike or a drop in the error codes that I have in my AWS account, then that's a filter. Why am I seeing a spike in error activity, or why am I seeing a drop in the error activity? Spike is basically when someone is trying to do an activity which is not authorized and a lot of error occurs. Drop is when you actually delete those error events than usual. Suppose you are having 100 error logs a day, and that's the usual thing for last 3 months, and you suddenly see no error logs for 1 day. What happened? Did the error actually stop coming in, or some activity deleted those logs? What those kind of things. So what we do is basically load those into a data frame. We select our features very carefully. So here we have our features which is source IP address and error code. I want to know what IP address is causing the most number of error codes. Is it an internal IP? Is it an external IP? Then I just do some data manipulation, which is basically cleaning up of data, anything which doesn't have data or data that is not in a particular format, clean up those data. And then I use something called an auto encoder for doing an anomaly detection here. I have an encoding layer of 2, which is the number of neurons in my inner layer. You can just customize that layer to your own own use case. Here I'm going to use an optimizer for Adam and mean square error for my loss function. And I'm going to run it in 50 epochs, which is 50 iteration or 50 loops. A batch size of 32. That means I take 32 things in one batch and run it for 50 epochs. And here basically I'm calculating my threshold, and my threshold for anomaly. Usually you can use a threshold saying that anything which is above 95% of total data point is an anomaly. But here what I do is twice of mean square error, twice of standard deviation and addition of mean to that. This basically tells me that any data in any data points, this particular equation, twice of standard deviation plus mean, is gonna give you 95% of the data points. So anything which is outside this would be an anomaly. So after I calculate this, I'm trying to calculate the reconstruction error and plot everything. So if I run it for 50 epochs, I get a graph something like this, which means anything which is on the right side of this dotted red line is an anomaly. And you have to look into the case why that's an anomaly. Anything on the left is actually okay. So can you scroll up on? Yeah, thanks. A bit low. Yeah, thanks. So these are the anomalies which have been split out. So I probably had a couple of 100,000 of events, and 2,000 events are actually anomalous here. And the account ID looks like exponential because that actually took it as float instead of a string. But what it says is basically, you see all these account IDs and all these error codes. The unique error codes are all here. So you just have to look into some specific error codes which have been caused by IP addresses and see what's the reason for those. And given names are here, which is like clean cloud stream or decrypt or update instance. So specifically spitting out any anomalous activity, which is a spike or a drop, using machine learning so that you can actually look for things which are unknown. So here in this case, I don't have to write a query saying that, okay, look for any activity which is creating error code. But looking for an activity in general and figuring out if there is a spike or a drop on a daily basis or on a unusual basis. That's what we're going to be looking in here. Now, going back to PPT. Yeah. No, that was it. Phong, just slide down. Yeah, next slide. The takeaways from here. So we saw the challenges with traditional threat hunting. Why traditional threat hunting is not the best approach to do traditional threat hunting today. How can we leverage Jupyter to do threat hunting, which is basically have a Jupyter notebook hosted on an AWS environment or Azure environment, query your data lake on object storage, grab all the logs, write a detection query, generate alerts, send it to your SIEM solution like Splunk, Sentinel, QRadar, anything. How can we enhance that hunting with machine learning, which is basically using autoencoders or anomaly detections or clustering or classification? Then how can we automate the hunting methodology? So whole process that we did, which was reading the dataset from a CSV file, running a threat hunting detection logic, and then generating an alert. Everything can be automated using a flow or a pipeline, which can query your S3 bucket, run your detection, generate alert, send it to a SIEM solution. And the ease of adoption and integration, since Jupyter is very easy, like user-friendly, can be adopted can be integrated into AWS environment, can be integrated into Azure environment, can also be integrated into Google Cloud Platform. So very easy to adapt and integrate to your existing infrastructure. And if you guys got any questions about anything that we have discussed, please feel free to bring it up. Yeah. Yep.
So my question is to the Azure. So what value do you get from using Jupyter that's compared to Crystal Node, which is native to Azure?
So as I say, some function like data manipulation that Crystal doesn't have. For example, email subject, when attacker sends you a million or 10,000 different subject email, phishing email. So how can you do that to search for similar string inside Crystal? Like for example, document, random character, and then some username, right? We have to pipe those data out to Python and use dflip to compare the string we set, and then the list of subject. And then when the data return, we have a threshold about that. Like if you want to look at like really similar string, you can set a threshold like 0.7 or 0.8. And then you graph those out. It's going to be a similar subject. And then you go funding from those needs. You can do those things inside Data Explorer if you have a Python code.
Any other questions? Yep.
I also saw
Sorry, is it for me or Phong?
yeah.
For the network.
Platform, right?
Network X, yeah.
Yeah, I was wondering what those are.
That's useful when you graph thing like from node to edge. Like for example, you get a list of user and then what action they can perform inside your organization. Like you can graph, okay, me have access to admin group, and then Kai have access to user group, and then this user group have access to certain resource inside Azure. It's like Azure Home. If you have ever used Azure Home or Blood Home, they kind of similar thing. You grab everything. You can do so that for red team simulation. You can graph the whole attack path and then you follow that path.
Okay.
Thank you, guys.